It takes Susie to drive from home each morning. The time is normally distributed with the mean of 35 minutes and the standard deviation of sigma minute. So we do not know sigma, and later we need to find it here. Question A. On 25% of days, it takes Susie longer than 40 minutes to drive to work. Find the value of sigma. It is given here the percentage 25% of the day. For example, in 10 continuous days, in 10 days, there will be about 1/4 of that. And let's take like 100 days. There will be like 25 days that Susie will need to spend more than 40 minutes to drive to work. And to find the sigma here, we need to use the standardization method and inverse normal that we used to do a question like this pretty long time ago, huh? Standardized process, meaning okay, let me illustrate that. A normal distribution curve. Normally we have the mean here right in the top middle of the bell, and the value the mean is 35 minutes. It's one standard deviation, 35 plus sigma. The difference between these is the sigma. We need to standardize this thing to be a normal distribution as well, but the mean will be 0. 35 here will become 0. And the real standard deviation sigma will become 1. Okay?
Okay.
That become 1. And to do that, we use a thing called a z-score. Z-score for the value 40. It takes her more than 40 minutes to drive to work, and that percentage is 25%, which means, okay, the value the value 40, for example, it is here. The area under this curve, on the right, greater than 40 is 25%. This area is 25% of the whole area under the bell, okay? The z value of 40 is 40 minus the mean 35 over the standard deviation sigma. We've done this kind of question, similar problem like this before. Do you remember?
Yeah.
Okay, using the z-score with the calculator here. No, not this one. Each student, each type calculator. Before calculator. The z value here is calculated using the inverse normal. Inverse normal. Go to statistic, huh? Distribution, normal, and then inverse normal here. Okay, inverse normal. The type data is variable, not the list, variable. The tail is on the right, 25% on the right, okay, choosing right. And then the area of that right area is 25%, which is 0.25, okay? And sigma is 1, mu is 0 by default. We just need to keep it there. Do not change it, 1 and 0, okay? And then run the calculation. Inverse of that, the value of that inverse is 0.67445. 0.67445, and we need to write here the complete, write 0.25 in the order of the calculator, 1 and 0. Just follow the order in the calculator, okay? 1 is the standard deviation and 0 is the mean, and it equals to 0.6745. From this, we can calculate sigma easily, huh? Sigma is this difference, meaning 5, divided with 0.6745, okay? You should take the the most accurate value here. Take the whole value here when doing the division. 5 divides this 0.6744895. 7.41. 7.41 minute. This is the standard deviation, the answer to the question A. For marks, it worth learning that. First step here, second step, third step, and finally, this is the last step. Fourth step for 4 marks. And usually 99% the result is written in 3 second figures. 741, 36, okay? 36. Checking the answer also. So here, question 9. Yeah. Normal curve greater than, they do not attempt to show graphically, meaning this curve is called a graphical solution, or using GDC, of course. Okay, that is the solution. Question 1. Do you want to do it again, or we can move to question B? Okay. On randomly selected day, for the probability that Susie drive to work will take longer than 45 minutes. The next question is kind of simple also. So among these 6 questions, A, B, C, D, E, E, at least we can do at least 3 questions, A, B, C. So do not skip the whole question. At least try to do half the question, because as you see, we can learn, definitely can learn to solve at least 3 questions, A, B, C. 4, 2, and 3, half the amount of marks. Okay. The next question B is pretty simple. Just use the calculator with the calculating the probability from one value to another value, like this. Going to the menu to statistic again, and then go to distribution, normal distribution, calculating NCD. C here, the letter C stands for cumulative distribution, meaning calculating a probability for the values in a range, ranging from one value to a lot of value in a range, from a lower boundary to the upper boundary. And in this case, we'll take the lower boundary to be 45 minutes. Okay, because the question is the time she drive to work, more than 45 minutes, from 45 minutes to infinity. Even though the time is not infinite, it can be like a few days if she's stuck in a heavy traffic jam. But theoretically, we need to put here the upper bound to be a very big value, like 99999. Okay, but or you can put in when writing in the test 2 power 99 something. It will give the same result, but the point is this upper value must be very big, infinitive time. It take her forever to go to work, or like she is driving to the work and she suddenly feels that she's so bored of work, she don't want to work anymore. Doesn't want to work anymore, to go home. So very infinite time. And then sigma, the mean is 35 minutes, and mean is below here, 35. The upper value is the standard deviation, sigma standard deviation we've just calculated, and try taking the most accurate value as possible, taking 4-5 decimal point. Okay, 7.413011. 413011. Okay, one more one. Okay, then run it, and here the answer, 0.0886, meaning about 9%. 9% is the probability, the percentage of the time that she takes. It takes her more than 45 minutes to get to work. 9 days among 100 days, that takes longer than 45 minutes. Okay, and the solution, of course, we need to write in the x follow normal distribution. with the mean 35 and the variance of 7.411. Let me see that value again. Oh, we can check here, this thing, okay, square it. And then the probability of x greater than or equal to 35 is 45 minutes. Is normal CDF, okay. Lower boundary 45, upper 2 power 99, mean 35, subdivision 7.41, okay, and equal to 0.08889, okay.
I have a question. Would I have to square the 7.41 again?
That is the rule. This thing inside the bracket is the variance, not the standard deviations. Variance is the square of the standard deviation. That is rule when we want to represent a normal distribution for readers.
Okay.
Question C. Susie will be late to work if it takes her longer than 45 minutes to drive to work. 45 minutes is a late. It will be to get a penalty, a decrease in her salary, like what's it called? A fire, khoản tiền phạt.
Yeah.
45 minutes to drive to work. The time it take to drive to work each day is independent of any other day. When we see a word like this, independent, we would think about the binomial distribution. I will remind you about the three assumptions, or in other terms, three conditions for a binomial distribution. 45 minutes to drive to work, time it takes to drive to work each day is independent of any other day. Okay, so this is one condition of the binomial distribution. Those three assumptions of the binomial distribution are binomial distribution. Three assumptions. Firstly, there are two outcomes which are mutually exclusive: success or failure. Success is not late. Failure is late, being late. Okay, failure.
Okay.
They are mutually exclusive. Secondly, the probability of a success or failure is a constant probability. For a success or a failure. And lastly, the events are independent from each other. So there's like an equal probability that she's late for work because of the traffic jam along her journey. Okay. Find the probability that she will be late to work at least one day next week. In a binomial distribution, we need to know three things. Binomial distribution, we need to know the number of trial ends. How many times she go to work in that week or that month, and okay. Secondly, the number of success. How many times she lays, that is x, okay. And the last thing is the probability of her success. But this is not success, this is failure. But normally we say the success about the binomial distribution, like winning a lottery. Okay, probability of success. In this case, it's a being late, and that probability is this one, 0.089. Okay, so that is the reason why we cannot answer question C without answering question B first, 0.98, and we should take as accurate as possible with the value here, taking 3445 decimal point, 8867. Okay. Number of trial. Look back at the question again. Find the probability as you relate to work at least one day next week. How many times you go to work each week? Meaning I'm looking for the number of trial related to work at least one next week. But from each morning normally distributed mean I assume that she work 5 days a week, meaning 5 times, huh?
Yep.
Wait, here 22 days 6 months. For the probabilities we believe for at least one day next week. Next week she work 5 days a week. Oh yeah. Wait, yeah. I didn't read this row. Okay, yeah. So that number of trial is 5. Yeah, at least one day either the value x. And to solve this question C, we will use the binomial distribution. But which one? N, B, PDF or CDF? Is it? Menu again, huh? Statistic. Okay, distribution, binomial here. Similar to the number distribution, we have the two functions PDF and CDF. Huh? PDF, again, similar to normal distribution, is to find the probability of getting exactly one single value. The probability of being late exactly one time among 5 days going to work. Okay. So PDF here is the one we use and right now for this question C. Okay. And CDF is to find the total probability that she being late, for example, from 1 day to 3 days, meaning you need to add the probability of being late 1 day, add it with the probability of being 2 days, 3 days, and 4 days, and so on, depending on how many times they ask later. We'll see if we see a problem like that using CDF at least or something. At least meaning could be late for 1 day or 2 days or 3 days or even 5 days.
So we're using BCD.
Yeah. We need to use the PDF, not CDF. PDF. Okay. Change that. At least 1 day, meaning they will take the sum of all the probability that she is late for 1 day or 2 days or 3 days or 4 days or even 5 days among the 5 day working, huh? Going to work. So change that. Distribution, binomial, CDF. Okay. Lower value is 1. Upper value is cost 5. Number of trial is 5. Okay. And this is the prop. Execute. Okay. Exactly the answer, huh? 0.3714. 0.3714. 37%. The total probability that she can be late 1 day or 2 days or 3 days or 4 days or 5 days.
So for these types of questions, do they usually accept a small range of answer, or does it have to be exactly 0.371?
Like I said, we usually take 3 significant figures, so you can take 0.371.
Yeah.
Or 0.37. I think they accept that too, meaning you 2 significant figures at least.
Okay.
At least, and yeah, we can see that they do not mention that in this mark scheme, so that like leaving for the teacher to decide if they accept 0.37 or not. But I think they do. I think they do 3 significant figure normally, and probably they do not accept like 0.35.
Okay.
So the wording is very important, huh? At least. This is the key to choosing PCD or PDF or CDF, huh? PDF. Question D. Given that Susie will be late to work at least 1 day next week given, the word given will make us think about a conditional property. Conditional probability. At least 1 day next week, which means we can use that formula. You remember that? If you don't, it's fine. Just open the formula sheet. The given property of A given B. The formula sheet is
Yep.
the property of A and B divided by the property of B. The property of B here is the property that is late at least one day, which is found to be 0.371. Okay,
Mhm.
and now we need to find the property of uh, probability that she will be late at less than 3 times. One day next week, probability that she will be late less than 3 times. Given that she will be late for work at least one day next week, she will be late less than 3 times. Okay, less than 3 times, meaning 2 times is the most. The property at the bottom here is the property that she is A and B. Okay, given that, I'm still confused if we need to use the conditional property or just the normal probability, which is the property of, but that 5 marks, I think that conditional, given that, at least one next week. Okay,
It's 5 marks.
three
So
times, less than 3 times, meaning the probability that she is late at least one and at least one and less than 3, meaning equal to 2 only. Because the question is simply less than 3 times. Less than meaning is not equal to 3. Less than 3, which is 2 at the most. Okay, equal to 2.
okay.
So the property at the top there, 1 x smaller than 2, is the binomial PDF with the lower bound is 1, the upper bound is 2. The number of trial is 5. The probability is 0.0888867. Okay, let me check the mark scheme first. Binomial greater than 1. No, this is C. This question is C. Okay, they're doing like the conditional here. Yeah, this is the formula of the conditional property. And this solution, the top, I'm hoping that my calculation coming on this calculator will be equal to this value, meaning I'm calculating the property on the top here. Okay, the lower boundary is 1, the upper boundary is 2. Okay, there, exactly, beautiful. 0.365. 365, and you just need to take as many decimal points as possible. 332, 32, and then that property of she being late at least less than 3, x smaller than 3, meaning equal to 2, given that x is at least 1. That is the meaning of this thing. Okay.
Okay.
Okay. Instead of this thing, okay, that is this thing is equal to this ratio. Okay. So in your solution, you write this solution. This is the reminding about the formula in the formula sheet, the booklet. Okay.
Is A the given or is B a given?
B is a given thing,
Oh, okay.
given
Okay.
x greater than 1. Okay. 0.36532 over 0.3714 in front here. Okay. Then I'll take this ratio 0.36532 divides 0.3714, 0.98, 0.9834. Wow, huge number. Yeah, so they are several wide range.
Yep.
Yeah. It means the meaning of this thing is that it is very likely for her to be late at less than 3 days, meaning it is very likely for her to be late 1 day or 2 days. Not a good
Yeah,
worker.
bad employee.
Given that, meaning if that happened, if she is late at least one, for example, if she is already late, already is given, okay, she already late 1 day among the 5 days going to work, it is very likely that she will be late again another day. Okay,
Yeah.
because a terrible traffic jam or her, laziness.
Mm,
Yeah.
true.
But if it is not a given condition or property, but just a normal property, the property that she is being late, taking longer than 45 minutes, it's just 9%. 9%. Meaning if she go to work like 100 days, there will be about 9 days that she is late. Okay, but the meaning of the question D here is if she is already late one day during 5 day going to work, it is
Yep.
very likely 98% that she will be late one more day.
Okay.
Nó hơi khó hiểu vậy.
Yeah, a bit confusing, but I still
Ờ,
get it.
nếu như mà không bị trễ ngày nào á, không không có cái điều kiện là bị trễ một ngày,
Yep.
thì 100 ngày đi đi làm thì cô ấy có thể bị trễ 9 ngày. Nhưng mà
Mm,
giả sử mình chỉ xem xét trong một tuần thôi, mà giả sử tuần đó bị trễ một ngày rồi, thì rất có thể 98% bạn cô ấy sẽ trễ thêm một ngày nữa.
mm,
Thì
okay.
cái chuyện là đã trễ một ngày rồi nó chính là conditional này. Cho nên
Yep.
là khi mà nó có một condition nào đó xảy ra rồi thì nó sẽ thay đổi hoàn toàn cái bài toán của mình. Kiểu như là cô ấy bị tai nạn cho nên nó có bị trễ một ngày rồi, cho nên ngày hôm sau cô ấy lại trễ tiếp.
Mm,
Hai cái bài part A, A, B and C, D nó khác nhau. Cái phía trên là chỉ là normal, cái bên dưới là binomial.
mm,
Dù sao nữa thì cái normal nó vẫn dễ hơn. Okay. Now, Susie will work 22 days this month. She will receive a bonus if she is on time at least 20 of those days. Được thưởng nếu như mà không đi trễ quá 2 ngày.
yeah.
Đi đúng giờ 20 ngày. So for this month, she has worked 16 days and being on time 15 of those days. So she has how many days left to go to work? 22 minus 16. Days 17, 17, 18, 19, 20, 21, 22, 6 more days. 6 more days going to work. And she is already late for 1 day because she's been on time 15 days. She already late for 1 day. So she allowed to be late for one more day.
Mm,
Okay. To get a bonus, she is not allowed to be late more than 2 days from today and greater. She is only allowed to be late for 1 day among 6 days left going to work so that she
okay.
can get that bonus.
Yep.
Okay.
I get it.
So the probability that she will get that bonus is the binomial distribution with the number of trials is 6 and the probability is 0.0. The thing here again. Wait, it's difficult because this value, the property 0.08867 is the property that she being late for 5 days going to work for 5 days. The number of trial is 5 days. But this last question, the number of trial is not 5 days, but 6 days. From 16 days to 22 days, 6 more days. So we need to find a new property, okay, for
Okay.
her to be late for the next 6 days. Late number of trials is 6. Number of trials 6. Okay. the prop of being late, sorry, the prop of being late is still 0.09867 here, because this is a property that the journey, the commutation, the trip takes her more than 45 minutes, meaning being late. So the property here is the same. The only thing that is different is the number of trial, which is 6 now, not 3, not 5. Okay. So question A, she can be late for 1 day at the most among the last 6 days going to work, huh? The last 6 days going to work to get the bonus. So the probability that she is late for one day, x equal 1, is the binomial. I forgot to consider the case that she is allowed. She also be a great employee worker if she is not late in the next 6 days. Meaning, we can add it with the probability that she is not late among the 6 days left. Okay, meaning here we need to take x less than 1, meaning from 0 to 1, and change the PDF to CDF. Okay, không trễ ngày nào, hoặc là trễ 1 ngày vẫn được thưởng. Okay. So change to CDF. I said at the most, meaning she can be late for 0 day or 1 day. I said distribution binomial PCD. Oh, sorry, PCD. CDF. Okay, binom CDF. The lower is 0. The upper is 1. The number of trial is 6. You need to enter those things, huh? Number 6 and the prop. Yeah, okay. The order is correct. 0, 1. Wait. I need to enter the lower boundary also here in front of the number 1. From 0 to 1. And 6 number of trials. Remember that this binomial distribution only deal with the integer numbers 1, 2, 3, 4, 1 day, 2 day, 3 day. They do not deal with the real number like 1.1, 1.2. Okay. From 0 to 1. Okay, and this property, the result is 0.907. Which means that it is very likely that she will get the bonus. Very likely. Congratulations. Okay, yeah, great answer. 16 day going to work, being late only 1. She's a good employee. So yeah, during the last 6 days, she is very likely to not be late for more than 2 days and get a bonus.